Hello, today we're going to work on lesson 2.8 reasoning. It's called Keeping Current. And our quote for the day is, "To me, the real state of the union is found in how Americans react to current events." And wow, that's pretty fitting for all the current events we have going on in our world right now. So let's look at, we have one main big problem. I have two sections I assigned, but the lesson check is in the first main big problem, and that's the only one we're going to do for lesson 8. It says, if you're like many students, you're concerned with the cost of attending college. It's certainly not a secret that college tuition has been rising rapidly over the last 20 to 30 years. But what are the facts? For that, we need some data. The following table lists the average cost of tuition and required fees for all four-year American colleges and universities for a variety of schools starting in 1980. So it's not all schools, it's a variety, and this is starting in 1980. So 1980 is our base year. Okay, so this is going to be 0. So on page 240, it says, to analyze the data and look for patterns, we've seen that scatter plots can be useful tools. We've also seen that when modeling data based on time, it's a good idea to choose input values based on time passed since the first data value we have. In this case, it's 1980. Fill in the table of values using the information in the last table. Your X value should be years since 1980, and your Y value should be the average tuition cost for that year. So we're going to put them in this table, and then we're going to go to Desmos and put them in X1 and Y1. Okay. So the first year is 1980. And we're going to put 0 here. And then 1990 is going to be 10 years. 2000 is going to be 20 years. 2010 is 30 years. And 2011, okay, this is a little bit different one. 2011 minus 1980 is 31 years. So you can't just assume that they're going by a certain pattern. And then 2012, the rest are going by ones. So this would be 33, 34, 35. 2016 is 36, and then 37. And then, of course, we're going to have our values here. You don't have to enter them all here because you're going to go to Desmos and enter them there. Okay, with your years. So let's go ahead and go to Desmos. And you can see here that I have all of the data in 0, 10, 20, 30, and then 31 through 37. And all of the average costs, average tuition costs of the data that they collected. Now, of course, number 2 is asking us to do a scatter plot. So we're kind of just walking through all of the things that we've learned in Unit 2. This is just a big round out question. So we're just going to kind of bop through all the things that we've learned. So number 2 is asking us to do a scatter plot. And remember to do that. We're going to go ahead and hit the zoom fit, the magnifying glass, and it should give us a nice scatter plot. Okay. So always just check to make sure you have your data in correctly. 13, 572, 14, 199. Okay, I'm just making sure I do as well. Okay, so question 3 says, based on your scatter plot, which type of equation do you think would appropriately model the tuition data? Linear or exponential? So this is just based on the scatter plot. And on the scatter plot, I'm kind of torn between linear and exponential. This looks kind of linear here, but then when it's connecting up here, I can see where it might turn to be exponential. And then just looking at these pieces, these single years kind of are curving in a weird way. So I could kind of go either way. Number 4 says using a graphing calculator or spreadsheet, find the linear equation of best fit. So we're going to find the line of best fit first. Okay. And follow along, but you should have reference of this from other lessons that we've done. This is our Y1. So we're going to go here and we're going to say Y1 tilde MX1 plus B. And now remember the line of best fit, they automatically give us our R and our R squared. The R is what we want to use to decide. So number 4 says the line of best fit. And the line here is, the slope is 414.94, 414.94x plus our y-intercept is 574, and we'll round that to 80 cents. Okay. Number 5 says graph the line of best fit in your scatter plot on the screen, which we did. Looks pretty good. I think it looks like it fits well for number 5. And then number 6 says, what is the correlation coefficient for your equation of best fit? Does this change your perspective on how accurately the model fits the data? Explain. So remember, we introduced this back in lesson 2.6 and 2.7. So R, the correlation coefficient, is right there above the parameters. It says R equals 0.9915, which is very close to 1. So it is a good fit. So at this point, it looks like linear model is a very good fit. Okay, and I'm going to go back to my paper so that you can all see what I'm writing here for the different answers. So I said it could go either way. Here's what we type in Desmos to get our line of best fit, linear. There is our slope and our y-intercept. Then when I looked at the scatter plot, I thought it looked really well when the line of best fit went over my scatter plot. And then number 6, looking at my correlation coefficient, being very close to 1, this is my correlation coefficient. I think it looks like it's a good fit so far. So let's flip the page. Number 7 says, write a description of what the slope of your linear model tells you about the growth of tuition since 1980. Be very specific. So we have really been practicing this on the worksheets. So my slope is 414.94. And remember, it's over 1. In my units, it's delta y over delta x, right? That's my slope. And so my units on my y's are right here. The cost, right? So dollars and years. So this is dollars and years. So then we're going to say each year. So I'm going to refer to the exchange. We can expect the average cost of tuition. So I'm describing the X, right? And then I'm describing the Y. So each year, that's the 1. Each year it's going up by 1. We can expect the average cost of tuition to increase because the slope is positive, to increase by, you could say approximately if you wanted, $414.94. Now use your calculator or a spreadsheet to find the exponential equation of best fit for the data. Again, round all coefficients so that they have 5 total digits. So we're going for the exponential equation of best fit. And a quick reminder of how you're going to type that in. So that's going to be y1 tilde a times b, and then in the exponent, it's x1. Okay. We're going to go to Desmos and do that. And it's going to ask us to put that over the line, which Desmos automatically does that. And then number 10, just so we can look ahead, is going to be asking us for a description of what the base in your exponential model tells you. And remember, the base is our growth factor, which is B. So we're going to look for that. So we're going to find our exponential equation of best fit. We're going to have it on the scatter plot and just see how it compares to the linear. And then we're going to go to 10 and we're going to look at what that growth factor tells us. Now, the growth factor is kind of like the rate of change, just like our slope in a linear model is our rate of change. Let's go back there. Okay. So now we're going to go down here. I'm going to start a new line and I'm going to do my exponential model best fit. So y1 tilde a parentheses b parentheses to the exponent of x1. And if you're having trouble still finding how to get the exponent, you can always click on your show keyboard and use either the a squared and then go up and edit the 2 to be an x1, or you could do an a to the b and create your exponent. Also, remember that we don't see the R right now because we have to click the log mode box. So there we have our model equation, exponential equation of best fit. So it's y equals a is 1976.34 times 1.06 173 to the x. And the red doesn't look like it terribly fits, does it? Because of these, like if you look here in those single years, it doesn't really look like that's fitting as well. And notice that the R, the correlation coefficient, isn't quite as strong. It's 0.991 instead of 0.9915. So, okay, let's go back to our paper so we can fill this out, answer these questions here. So there's our exponential equation of best fit, our A and our B. And then, do we think the graph fits as well? Not quite as well as the linear. And then it says, write a description of what the base tells you. Okay, so the base is our growth factor, which is 1.06173. Our growth factor, remember, that's our multiplier to go from one output to the next. But our growth factor is used to really get us to our relative change. Now, some of you can see what it is right from here. Others need to kind of use this formula. So our relative change is by taking B, that growth factor, and subtracting 1. So 1.06173 subtracting 1 leaves us with 0.06173. I'm just going to put the 0 in front just so it looks prettier. And then we're going to turn that into a percent. So we move our decimal twice to the right. So it looks like 6.173% increase per year, because this is a rate of change as well, right? Relative change is a rate of change. So 1.06173. So it looks like about 6.173. And we can see that if we were to take and take 1,679 and multiply it by the multiplier 1.06173, we should get close to the next output of 4,009. Okay, number 11 is our lesson check. It says, what is the correlation coefficient for your exponential equation of best fit? Does this change your perspective on how accurately the model fits? Explain. And our exponential, I'm just going to go back so we can go back and look at that, is 0.991. And it asks us to round it to 2 decimals in decimal or in JetNet. So 0.99 should work. And it's just not quite as good. It's not quite as strong as the linear. And the number 12 here, so let's go back to that. I just want to make sure we have everything, all the details in here. Okay, so we're going to go back to my paper and answer our last question, number 12. So it says, based on all the work we've done in this portion of the lesson, which model do you think is the best choice for modeling the tuition data in the table? Why do you feel that way? So I would choose linear because the R is equal to 0.9915 is closest to 1. The scatter plot agrees with what we said above. And those are my choices. So when we're looking at an overall problem, so for the Unit 2 project, you're essentially doing these same steps. You are gathering 10 days of data for your stock price. You're going to do a scatter plot. I'm asking you to do the line of best fit, to do the exponential equation model of best fit. You're going to be assessing your correlation coefficients for each, and then you're going to let me know what your choice is. And once you make your choice, then you're going to describe your either your slope if it's linear that you choose, or your growth factor if you choose exponential, and then some other questions about that and doing a little predicting. So hope you've enjoyed Unit 2, and we'll be moving on to Unit 3 after the midterm.